Hey guys, welcome back. So today we will review simplifying expressions with negative exponents. Let's look at our first example. So in this example here, we're going to go ahead and separate 4x squared times y to the negative third because I want to bring this y to the negative third in my denominator to make positive. This is going to equal 4x squared times 1 over y cubed. Now we're going to multiply 4x squared times 1 is 4x squared. And then you have this imaginary 1 under here as well. So you have 1 times y cubed, which is going to give you y cubed. So your final answer is 4x squared over y cubed. Next, x to the negative fifth times y to the eighth. So first I'm going to bring my negative fifth to my denominator to make positive. So we're going to do 1 over x to the fifth, and it is now positive, times y to the eighth. So 1 times y to the eighth is going to give me y to the eighth in my numerator. And then when you're multiplying x to the fifth, it's like you have an imaginary 1 right over here. So x to the fifth times 1 is going to give you x to the fifth. So your final answer is y to the eighth over x to the fifth. So let's try this example here. Let's go ahead and simplify. We have 8x to the fourth, and I want to bring this y to the negative fifth in my denominator because to make positive. So y to the fifth is here. And then we have z to the negative 1. That's also going to be in my denominator because I want to make that positive. All right, and to simplify, I'm just going to simplify this z to the 1 right here. Everything else is already simplified. 8x to the fourth. That's good. I don't need to simplify that. And then we have y to the fifth times z. So this is your final answer here. All right, so let's try this example here. We have -5 and -2. I'm going to bring these down in my denominator. So my 3 is going to stay the same. That's perfectly fine. And I'm going to bring down my x to the fifth in my denominator to make my exponent positive. And I'm also going to bring down the y to the -2. And based on this example here, I cannot simplify any further. So this is my final answer. Let's look at this example here. So I have x to the -1 times y to the negative third. I know I need to bring down this -1 and this -3 in my denominator. So I'm going to have a 1 over x to the 1 times y cubed. And to simplify, you're going to get 1 over x to the 1 is x times y cubed. And this is your final answer here. What if you had 1 over 2 to the negative third? This time, my -3 will be brought to my numerator to make positive. So this will turn into 2 to the third. 2 to the third equals 8. So your final answer in this example is 8. What about 1 over 3 over 4 to the -2nd power? In this example here, notice that the -2 applies to the 3 over 4. So if I want my -2 to become positive, this is going to turn into 3 over 4 squared. So this turns into 3 squared over 4 squared. And this is going to equal 9 over 16. And your final answer is 9 over 16. Let's try -2x to the -5th times y. The only thing I do need to bring down in my denominator to make positive is my x to the -5th. So this is going to look like -2x to the 5th in my denominator times y. So I do not need to simplify any further. So my final answer is -2y over x to the 5th. Let's try -3x to the -5th. My -5 applies here to the x. So this is the only thing I do need to bring down in my denominator. So this is going to equal -3 over x to the 5th. And this is your final answer here. A common mistake is to turn this into 1 over -3x to the 5th, and this is not the correct answer. This is a no-go because my -5 only applies to the x in this example. Let's try 2x -3 over y -4. So I know I have a negative here and here. So this is going to look like 2 over x cubed, because that's going to be positive now. And then the y is going on top, y to the 4th. and I do not need to simplify any further. So this is my final answer here. Okay, so let's try this example here. Notice that the negative exponent applies here to the 5. So I know I need to bring this down to my denominator. So this is going to look like you have a 1 over 5 to the first power times x squared, which is going to equal 1 over 5 to the first power is 5 times x squared, which is going to equal 1 over 5x squared. Okay, so let's try this example here. I have negative exponents here at the y and here at the z. So first we have 4 over 5. I do not need to simplify the 4 over 5 any further, so I'm going to leave that alone. And then we have times x. My y cubed is coming to my denominator because that's a negative exponent. Z to the negative second power is going to the numerator. That's a negative exponent. And then at the bottom here, we have w to the 0 power. And in this example here, the only thing that I need to simplify further is this. Remember, anything to the 0 power equals 1. So this is going to turn into a 1 right here. So this is going to look like 4xz squared over 5 times y cubed times 1. So this is going to equal 4xz squared over, you have 5 times y cubed times 1 is going to equal 5y cubed. So this is your final answer here. What if we had negative 3 squared times negative 3 to the negative third power? Because my bases are the same, I'm going to add my exponents. So this is going to look like negative 3. I'm keeping my base. And then you're going to add 2 plus negative 3. So 2 plus negative 3 equals 2 minus 3, which is going to give me a negative 1. So this is going to equal negative 3. 2 plus negative 3 we said was negative 1. And because I have a negative exponent, so I'm going to rewrite this as 1 over negative 3 to the first power, which equals 1 over negative 3. Or you may also see like a negative 1 over 3. It's the same thing. This is your answer here. All right, so let's try negative 2 to the negative first power times negative 2 to the negative 3. Since my bases are the same, I'm going to add my exponents. So this is going to look like negative 2, negative 1 plus negative 3. So negative 1 plus negative 3, which is going to equal a negative 4. So I'm going to get negative 2 to the negative fourth power. Now I have this negative exponent, and to make positive, I'm going to write 1 over negative 2 to the fourth power, and negative 2 to the fourth power equals 16. So your final answer is 1 over 16. What about 4 to the negative 3 times 4 to the fifth? So bases are the same. So I'm going to add my exponents. It's going to look like 4 negative 3 plus 5. So negative 3 plus 5 is going to equal a positive 2. So this is going to be 4 to the second power, which is going to equal 16. So your final answer is 16. What about 3 to the negative 4 raised to the 0 power? Remember, anything raised to the 0 power is going to equal 1. So this answer is going to equal 1, but let's go ahead and show our work. So I'm going to multiply the negative 4 times 0. So this is going to look like 3 negative 4 times 0, which is going to equal 0. So this is going to look like 3 to the 0 power, which equals 1. So your final answer is 1. So let's try this example here. I'm going to multiply negative 3 times 2. This is going to equal 2 to the negative 6 power. Because I now have a negative exponent, I need to make that positive. This is going to look like 1 over 2 to the 6, which equals 1 over 64. What about 5 to the negative 1 raised to the negative second power? Okay, so I have a power raised to a power, so I'm going to multiply. So this is going to look like 5 negative 1 times negative 2, and negative 1 times negative 2 is going to give us a positive 2. So this is going to look like 5 to the second power, and 5 to the second power equals 25. So this is your final answer here. Let's try x cubed times x to the negative 4 raised to the second power. All right, so I'm going to leave my x cubed the same. I do not need to simplify that for now, but I do have a power raised to a power, so I'm going to do x cubed times x negative 4 times 2. This is going to equal x cubed times x negative 4 times 2. This is going to equal a negative 8. So this is going to equal negative 8. Now I'm multiplying two products with the same base. So that means I'm going to add my exponent. So this is going to turn into 3 plus negative 8. And if I have 3 plus negative 8, this equals 3 minus 8, which is going to equal a negative 5. So this is going to look like x to the negative 5th power. And because now I do have a negative exponent, to make this positive, this is going to look like 1 over x to the 5th. And this is your final answer. Now, you could have done this another way as well. So let's move up here. So let's say we had x cubed times x to the negative 8th power. And we know that we do have a negative exponent here. So technically, I could have just turned this into a fraction. So this would look like x cubed 1 over x to the 8th. And if I multiply straight across, you have your imaginary 1 under here. This will look like x cubed, because we're multiplying across, over x to the 8th. And then you could have subtracted here. So this would have looked like x3 minus 8, which is going to give you x to the negative 5th power, which equals 1 over x to the 5th. So you could have done this a different way and you would still get the same answer. So let's try 5 over 2 raised to the negative 2nd power. This pretty much means we have 5 to the negative 2nd power over 2 to the negative 2nd. And I have two negative exponents, so I'm going to bring them down. So I have my 5 to the 2nd power in my denominator, now that it's positive now, and then my 2 to the 2nd power in my numerator. So this is going to equal 4 over 25. What about 2x negative 1 over y all raised to the 3rd power? So we're going to simplify. So we have 2 to the 3rd times x. We're going to multiply the negative 1 and the 3 here. So you have negative 1 times 3 all over y to the 3rd. So 2 to the 3rd, we're going to simplify here. This is going to give me an 8 times x. Negative 1 times 3 is going to equal a negative 3 over y cubed. And I now have this negative exponent, so I'm going to bring that down to my denominator. So this is going to equal 8 over x cubed times y cubed. So let's try this example here. This will be our little bonus question. All right, so first thing first, we're going to start with our numerator. We have negative 2 cubed. That's going to give me a negative 8. And then we have x to the 4th. The 2nd power is going to the y and the 2. So this is going to be x to the 4th times y squared times z squared. So 3 squared is going to give me 9. And then we have times x times y cubed times z to the 4th. Because I'm dividing with the same base, I can definitely subtract my exponents. So I have negative 8 over 9, and we have x4 minus 1, y2 minus 3, and we also have z2 minus 4. Let's see if I can squeeze down here. Negative 8 over 9, you have x to the 3rd power. This is going to give me 3. y2 minus 3 is going to give me y to the negative 1st power. And then you have 2 minus 4. This is going to give me z to the negative 2nd power. And I do have negative exponents here. So I'm going to get negative, we're going right here. So we're going to get negative 8 over 9 x cubed. And then my y to the 1st power is coming to my denominator to make positive. I'm also bringing down my z to the 2nd power. And only thing I can simplify is my y to the 1st. So this is going to equal negative 8 x cubed over 9 y z to the 2nd power. And this is your final answer here. All right, so that is all for today, and I will see you all in the next video. Bye, guys.